All right, let's jump right into this explainer. Today, we're unpacking a high stakes, multi domain battle to see how modern warfare is actually fought on the ground, in the air, and at sea. You see, it's not just about who has the biggest weapons anymore, it's this chaotic, high speed dance of technology, timing, and data. So think about this for a second. How do you rewrite an entire complex battle plan in 60 seconds without anyone saying a single word? The answer to that question actually reveals the true victor in today's combat. When most of us picture a modern battle, we probably imagine jets screaming overhead, massive ships, and huge explosions. But the reality? The absolute most powerful weapon in the battle space is the invisible network connecting all of those assets together. And to really understand how crucial this is, we have to look at a scenario where a meticulously crafted plan starts falling apart before it even gets off the ground. Okay, let's start the clock. It's 1706 local time, and 9 Tomahawk cruise missiles launched from a U.S. destroyer, dropping down low to skim the wavetops of the Gulf of Oman. At first, it looks like a completely flawless launch, but just 4 minutes in, an Iranian radar operator on the coastline ahead sweeps the water and spots them 40 kilometers out. Now, according to standard physics, spotting a missile flying just 10 meters above the waves from that distance should be literally impossible. They should be completely hitting behind the curve of the Earth. But this operator trusts his eyes and instantly puts the entire coast on high alert. So what happened? Well, the culprit is a wild weather anomaly known as an evaporation duct. The intense summer heat over the Gulf had quietly rewired the physics of the environment, completely free of charge. This blanket of warm, wet air essentially trapped the radar energy and bent it far past the normal horizon. It gave the coast an early warning that instantly broke the U.S. strike plan. Suddenly, the stopwatch is running on both sides of the beach. The U.S. strike package had a jamming sequence carefully scripted for 18 minutes later, which was the exact moment the Tomahawks were supposed to cross into that radar's normal horizon. If they stick to the script and wait, the coastal radar tracks the missiles cleanly and hands the coordinates to every surface-to-air battery on the coast. But if they jam right now, the electronic noise itself announces the strike 12 minutes early. So a U.S. Growler jet crew has to adapt on the fly, using Link 16, a highly encrypted data network, to completely rewrite the entire battle plan mid-flight in under a minute, without anyone keying a radio. And honestly, this is a perfect textbook example of SEAD, the suppression of enemy air defenses. The Growler is a specialized jet rebuilt entirely to carry jamming pods instead of traditional bombs. It doesn't pick fights of its own. Its one and only job is to blind the enemy. The crew floods the coastal radar's frequency with raw, overpowering noise. And just like that, the operator's impossible contacts instantly dissolve back into static. Meanwhile, back out on the U.S. destroyer, they are facing their own ticking clock. A brand new, sea-skimming track suddenly appears on the edge of their radar picture, flying incredibly low and fast, right on the water. It's an incoming Mach .9 NOR anti-ship missile, and the brutal math of a wavetop missile at that specific range gives the ship just 9 seconds. 9 incredibly short seconds before the missile crosses inside the threshold where point-blank last-ditch defenses have to take over. And here is the truly terrifying part of those 9 seconds. It's kind of like 2 identical cars merging onto a highway, and you have a split second to guess which one is the getaway car. The ship currently has its own identical Tomahawk missiles flying outbound through that exact same patch of sky. The Aegis combat system and the Cooperative Engagement Capability Network, which basically fuses every ship's radar into a single shared view, have to instantly confirm if this contact is a friend or a foe. It calculates that the incoming track has no friendly birth certificate. Immediately, an SM-2 interceptor screams out of the forward cells, swatting the enemy missile out of the sky just 11 miles from the hull. All right, let's move about 60 miles inshore and see how this builds into an entirely different kind of trap. An Iranian Khordad missile battery has set a perfectly silent ambush for a U.S. F-18 strike lead, going by the call sign Uppercut 21. Now, instead of using a standard radar, which acts like a loud flashlight in a dark room and practically begs for an anti-radiation missile to hit it, they are hunting with an electro-optical tracker. It's essentially a stabilized thermal telescope that watches for the hot exhaust of a jet against the cool sky. It is completely passive, so to the F-18's radar warning receiver, the sky sounds fatally quiet. Uppercut 21 is flying right down the bearing of this silent ambush. The Khordad crew tracks him with the telescope until the very last possible moment. Then, snap, they turn their engagement radar on. The radar warning receiver inside Uppercut 21's cockpit goes from dead silent to an absolute shriek instantly. A Mach 3 missile screams off the rail, leaving the pilot with a razor-thin 3 seconds of margin to react. But remember that Growler jet running the SEED mission? Following the very first absolute rule of this highly networked war, which is, turn on your radar, you lose everything. It instantly detects that new emission. The Growler fires a HARM, anti-radiation missile, straight down the enemy's radar beam. Knowing this high-speed missile is coming right at their heads, the Cordad crew is forced to shut off their radar 3 seconds too early just to save themselves. Because of that, the Mach 3 missile they fired loses its guidance, goes completely dumb, flies wide, and Uppercut 21's life is saved. Okay, jumping back to the coast, those inbound Tomahawks are dealing with their own electronic hurdles. As they approach the shoreline, an Iranian ground jammer completely drowns out their GPS signal. But these Tomahawks have brilliant fallback logic built in. When GPS fails, the missile seamlessly switches to step 2, inertial guidance, where it's basically counting its own steps to estimate its position. Then, as the coastline rises, it hits step 3, DSMAC. This is a camera in the nose of the missile that acts like facial recognition, but for buildings. You can jam a GPS signal all day, but you cannot jam a photograph. The missile matches the physical coastline to its stored imagery and locks dead onto its target. An Iranian Pantsir system, which is a truck carrying anti-air missiles and twin cannons, tries desperately to intercept these inbound Tomahawks. But remember, the Tomahawks are specifically programmed to sit just 10 meters over the sea. At that ultra-low altitude, the defensive radar's own surface clutter completely confuses the proximity fuses on the interceptor missiles. It's exactly like a motion sensor light in a rainstorm. Everything sets it off or nothing does. The defense is rendered totally useless just by the sheer geometry of the attack. You know, the planning math here is brutal, but it's incredibly efficient. Anything fixed, heavily defended, and known belongs to the Tomahawks. They slam 1,000-pound warheads through the roofs of the anti-ship missile shelters from 260 miles away. Meanwhile, anything that needs a human eye or a hardened, penetrating hit belongs to the F-18 Hornets, which follow up by hand-delivering 2,000-pound satellite-guided bombs, igniting massive secondary explosions all across the boat sheds. But hold on, because the battle isn't over. Out of those burning piers, a 40-year-old Iranian military doctrine suddenly emerges. Uppercut 21 looks down at his instruments and sees 30-plus surface contacts pushing out into open water. It's a swarm of dozens of fast boats scattering across miles of black water. The strategy is super simple. Disperse, close the distance fast, and force the enemy to solve 30 different problems at once to overwhelm the big, expensive ships. Now, the whole swarm doctrine relies on the assumption that the U.S. targeting cycle will be narrow and slow. If you just had one fighter sweeping its own narrow radar cone, it could easily let boats slip around the edges. But orbiting way up at 25,000 feet is an E-2D Hawkeye aircraft. Its massive rotating radar dome stitches every single tiny wake into one massive cohesive picture. It beams that picture over the shared data network, turning what should be a chaotic, overwhelming swarm into a neatly numbered to-do list for the fighters. But we've got to think about the economic math here. None of that amazing targeting data actually matters if you can't afford the ammunition to shoot the targets. Firing a $2 million Tomahawk at a cheap fiberglass boat means you fundamentally lose the war of attrition. Heck, even a $150,000 Hellfire missile is way too expensive when you're facing dozens of targets at once. The U.S. military knows this, which is exactly why they immediately pivot to a much cheaper option to handle the swarm. Enter the APKWS. It's a brilliantly simple piece of engineering. A $25,000 kit that just bolts a laser seeker onto a standard, cheap, unguided Hydra 70 rocket. With 7-round pods mounted under their wings, the F-18 Hornets can take over a dozen precise guided shots per pass. Because every single shot is cheaper than the boat it's aimed at, the pilots can afford to just work straight down the Hawkeye's list, turning the entire swarm into splinters without ever running their magazines dry. Meanwhile, back at the destroyer, the fight collapses to absolute knife fight range, where the margin for error drops to 0. The ship's Sea-Wiz, which is a close-in weapons system capable of spitting out 4,500 rounds a minute, suddenly tracks a fast shape, crossing the bow at just 200 feet. This system exists solely to stop a boat or missile charging the hull in its final seconds. It's literally like a bouncer swinging in a packed room. It has to hit exactly the right target with absolutely zero collateral damage. The heavy weapon mount slews hard onto the target, but perfectly holds its fire. Why? Because of a millisecond Mode 5 IFF reply. This is a coded digital question that every single American aircraft answers automatically, without the pilot ever having to lift a finger. That fast shape crossing the bow wasn't an enemy missile or an attack boat. It was just an empty, friendly F-18 Hornet heading home from the strike. And really, that brings us right back to the core takeaway for this explainer. Modern combat is essentially an air traffic grid laid over a chaotic bar fight. The true victor of this massive engagement wasn't the raw firepower of the bombs or the sheer speed of the jets. It was the invisible scaffolding of the data networks. Link 16, cooperative engagement capability, Mode 5 IFF, sorting every shooter, assigning targets, and preventing catastrophic friendly fire in a fraction of a second. It is a truly fascinating look at the hidden mechanics of modern combat. The technology allows for breathtaking speed and precision, but it leaves us with one massive, provocative question. If highly networked warfare relies entirely on these digital ties to function, just how vulnerable does a modern military become against an adversary who finally figures out how to turn those networks off?